We're finally into calculus, and first thing I want to do is introduce some new words and new notations. So the newest word, the first word in calculus is limit, and you will see that written like this. So I'll say the limit, and I will say as my x values are moving towards or approaching, let's say 2, and then I'll give you a function to look at, and then I will ask you to look at that and evaluate it. And so that's what this lesson is about. It's about evaluating limits or estimating them, because today's only with pictures. Okay, so this is the new notation. You'll write it like this. This is where your x's are approaching, in other words, the x value that you're looking at. Here's the function you're looking at, and the answer that goes here will be a y value. So you need to remember that. This is a y value that you're looking at. These are x values that you're looking at. So let's say I'm looking at this function, this red line. We'll say this is just some function. We'll call it f of x. And of course, here's my coordinate plane, this green line. So if I asked you for the limit as x approaches 2, what I'm going to do is I'm going to come over here, and here's my x's down here, of course. So x approaches 2 would be about right here, 1, 2, and I'm going to look to see what my y value approaches. And I can see that my y value is about, this is about y equals 3 up here. So this answer would be a 3. Okay, so again, this limit is a y value. It's right here. Now all you're doing is you're looking for, from the left and from the right, what are my y values getting closer to as my x values are getting closer to this x value right here, x equals 2. Okay, now it does not matter if this is actually defined right here. Even if this graph had a hole in it right there, and the line went all the way to the hole, and then there was a hole, and then the line kept going, the answer would still be 3. Because I'm only interested in what are the y values approaching. And from here the y values are approaching 3, and as I come down the line my y values are approaching 3 again. It's not what is the y value, it's what are they approaching. Now you must approach the same number from both sides, and that's why this limit actually exists. If I were to take this function and change it to make it look like this, maybe have a break in it, then this limit would now not exist. So we would say no solution or does not exist if from this side I approach 3, and from this side it looks like I'm approaching a y value of like 4, 4.5, something like that. So it doesn't matter if you are connected, but if you're disconnected, you know the y value will not approach the same number, and therefore the limit will not exist. Okay, so now I'm going to give a series of examples based on this function right here, and this function looks really strange, I know, but basically it comes down to here, then there's a hole, the value is defined here, but the value is defined to be -2. Jump back up here to the function as a horizontal line, open circle, close circle, up to here, open, close here, over to here. So if I asked you for the limit as x approaches 0 of f of x, which is my red function over there, what would my answer be? I'd have to come over here and look, and I'd say my x's approach 0 right here. So again, I'm looking at my x's, they're getting close to 0 right here, so I'm going to look at my y values at this x value, and y value also happens to be 0 right here. As I'm coming in from the left, I'm approaching 0. As I'm coming down from the right, I'm approaching 0. So this answer is 0. So here's a few examples over here I'd like to talk about. Limit as x approaches 3. So I'm going to come over here. Here's where x equals 3. So I'm looking at the left side of that and the right side. And I can see that from the left I'm approaching a y value of about 3, and from the right I'm approaching a y value of about -2. And so since these two y values are different, this is no solution or does not exist. That limit does not exist. Right here, the limit as x approaches 6 would be way over here, 1, 2, 3, 4, 5, 6, about right here somewhere. So here's where x equals 6. My y values for this function approach -2 from this side and -2 on this side. So the answer to this is -2. Right here, the limit as x approaches -8. That's 1, 2, 3, 4, 5, 6, 7, 8, about right here somewhere. Here's where x equals -8. So I'm going to approach my function from both sides. So here's my function from the left. Looks like I'm approaching a y value of about 3. And from the right, I'm approaching a y value of about 3. Because this is always 3. So this answer would be 3. Again, because from the left I'm approaching 3, and from the right I'm approaching 3. Now this is what typically confuses people right here. Just because there's a hole here and the function's defined down here, that doesn't mean that the limit doesn't exist. Remember, the limit's just what are the y values approaching. And the y values are approaching this spot right here. Now if I asked you, what is f of -8? Well, then you'd have to tell me f of -8 is -2 down here. Because here is where the function is actually defined. But these two aren't always the same number. So now let's get into some properties. The first property is if I have two functions that are being added or subtracted, this would read the limit as x approaches anything, this doesn't matter, of f of x plus or minus g of x, then all this can be rewritten like this. Each one can take the limit individually. So it would be the limit of f of x as x approaches anything, plus or minus whatever this was, that same limit as x approaches whatever that was, g of x. So essentially all I'm saying is you can split these two up into two different limit problems. Okay, the next property is if I have the product of two limits, I can split that up as two different products. Take the limit individually. This does not matter where you're approaching. So basically you can split up a product. So that was the second rule. Moving on to this rule, you would probably guess that you can split this up into two different limits, and that is true. Again, this can approach anything, except for when you put the limit on the bottom, as x approaches whatever, this whole bottom answer cannot be 0, because then you'd be dividing by 0, and that can never happen in math. But anyway, split up a quotient by taking two separate limits. Just make sure the bottom one's not 0. This last one's a little bit different. When you have a limit of a composition which reads f of g of x, you can split this up by pulling the f way out here and doing f of the limit as x approaches wherever g of x. So this is kind of a strange one we'll talk about, but here's how you handle a composition. So let's say I'm dealing with this one, limit as x approaches 0, f of x plus g of x. So what I'm going to do is just split this up into two different ones and treat it like two separate limit problems. So I'm going to do the limit of f as x approaches 0 and the limit of the g function as x approaches 0. So over here, the limit of this function as x approaches 0, that's right here. My y values look like they're approaching 0. This is a 0 plus the g function as x approaches 0. Here's where x is 0. So right here, as x approaches 0, my y values look like they're approaching maybe like 2. So we'll just say that's a 2. So the answer to all this is 2. So here's another one, limit as x approaches -4, and we're multiplying the two functions together. So I'll come over here to my f. I'm just going to treat these as two separate ones. So this is going to be a limit as x approaches -4 of f of x times the limit as x approaches -4 of g of x. Now you don't necessarily have to show this step, but this is what I'm doing, taking this two different times. So here's 1, 2, 3, here's where, somewhere around here is about where x equals -4. So I'm looking for my y value right there, which is this y value. So about, what, 2.5 or 3, we'll just call that a 3, times, come down here to our g function, where x approaches -4, that's 1, 2, 3, 4, that's right here. We can see that we're approaching two different numbers. From the left side, we're approaching a y value of 2, and from the right side, we're approaching a y value of like -2. So this does not exist. So 3 times no solution is no solution, or 3 times does not exist is a number that does not exist. So let's try this one. This is a composition, and we remember that we're going to split this up like f of the limit as x approaches -8 g of x. So we have to figure out what's inside of here first. This is just a really small problem that we can come down to our g function, and we can try to find the limit as x approaches -8, which is going to be 1, 2, 3, 4, 5, 6, 7, somewhere around right here. So it looks like my y value, see how this has an arrow, that this is going to continue. So my y value is going to be about 4 or 5 right there. We'll just call that 4. So since this has a continuation arrow, we know that this is just going to continue on that path and there's not going to be any breaks. So now I'm looking for f of 4. And you can figure this out with pre-calculus, regular old standard algebra. Come over here, f of 4, 1, 2, 3, 4. F of 4 is -2. This just means f of 4 means the function's value when x equals 4.